Hello everyone, welcome to my youth programming club. Today we will be doing another Leetcode daily challenge and the problem's name is Substring with largest variance. And according to the problem statement, the variance of a string is defined as the largest difference between the number of occurrences of any two characters present in the string. It is to be noted that those characters should be present in the string. You cannot take the frequency number of occurrences of the characters which are not present in the string. For an example, if the given substring is AB, you cannot take C and D as two characters to be considered for their occurrences, because any substring of this string, any substring would not contain C and D. Okay. Note that two characters may or may not be same. So it's not necessary that the pair that we are considering, in that pair the first and the second character are not same. You can also take the first character A and the second character A. In this case the variance would be occurrences of A which is 1 and occurrences of again A which is 1, and subtracting that would give us 0. So given a string S of lowercase English letters only, return the largest variance possible among all of the substrings of S. For those of you who do not know what is a substring is a contiguous sequence of characters within a string. For an example, ABC is a substring, but AD is not a substring since the characters are not contiguous. They should be contiguous. Okay, then few example test cases are given, and the major part of the problem lies in the constant part. So length of the string is given as 10 raised to power 4. So for this size of input we cannot write of n square solution or any solution with time complexity beyond n square. If you are not familiar with how input size determines the time complexity of the solution that would be correct, i.e. that would be accepted, I will provide the link of this GFD article in the description. So according to this article, between 10 raised to power 3 and 10 raised to power 6 of n log n of n of 1 and log n solutions are only accepted. So this is the case. And the third constraint is that all the letters are English lowercase letters. So if you are thinking a brute force way to generate all the substrings of a string, which is of n square, by the way, it would give TLE. So this approach is rejected and we won't be moving towards it. Another way to think about is, usually in these kind of problems, the hint for the solution that would be getting accepted lies in the constraints only. Here it's mentioned that lowercase English letters only in the string. So there are 26 English letters of lowercase, and if we are considering a pair, say for example first is A and another is B, then 26 into 26 pairs will be there, and for these pairs we can iterate over the given string and count their frequency Actually, we can apply maximum sum subarray problem approach here, which uses Kadane's algorithm. Pardon me if the spelling is incorrect. Those of who do not know what is Kadane's algorithm, I will be providing link in the description for a GFG article and another article which also explains Kadane's algorithm. To give a summary, Kadane's algorithm is applied on a problem where you are to consider maximum sum subarray in a given array of integers. So how we would be going to apply Kadane's algorithm in this problem? In this problem, if the problem statement, if for example the given string is a b c a b and we are considering the pair ab, if we are considering this as the higher frequency character and this as the lower frequency character, then for all other characters like C, we won't be considering them, we would be considering their contribution as 0. And for a higher frequency character, we would be considering its contribution to be +1 and lower frequency character to be its contribution to be -1. And the array will be converted in a series of zeros, +1 and -1. For A it will be +1, it will be +1, for B it will be -1. Now here you have to find the maximum sum subarray, which means which subarray would be having the maximum sum for this particular array. And Kadane's algorithm can be easily applied on that. So let's move towards the coding part. Here I have taken the frequencies of the given characters in the string, and then I have taken the combination for which will generate all the possible pair of all the English letters. The thing here to be noted is that if either of the character in the pair have a frequency 0 in the substring, means it's not present in the substring of the given string, then we will not be considering that case. And also in the case where both of the characters in the pair are same, you know the variance would be 0, because both of would be having the same frequency, and if we subtract same frequency it would be 0 and it will not contribute towards the largest variance or maximum difference. So maximum difference or maximum variance, whichever you may choose. And then a trickier part is in the Kadane's algorithm is here. This is pretty much the Kadane's algorithm, but we will only be considering the variance only when frequencies of both of the characters are greater than 0, i.e. we have encountered both of the characters, then only we will consider that subarray or substring. Basically substring and subarray are here the same thing, that's why we are not generating all of the substrings. For every pair we are just considering the subarray part which is having the maximum sum, that would be the variance that pair of characters is contributing, and we would be finding maximum of such variance. of any pair of characters that is present in the string. If it's not present in the string any of the characters in the pair, then we will not be considering. So this is where the Kadane's algorithm will be applied. Now there might arise a case when, for an example, the input will be like this. If I let me copy it and move to a new slide. For example, for this, if higher frequency character, we will always be fixing one character in pair as a higher frequency character and another as lower frequency character. Higher frequency character, this will be lower frequency character. It would be contributing +1 and it would be contributing -1 for the array that will be formed on which Kadane's algorithm will be applied. I am talking about this array. For an example, this was the higher frequency character A, this was the lower frequency character B. A was contributing +1, B -1. Rest all the characters, any character may occur, C, D, E, F. Their contribution will always be 0 since they are not considered as of now in this pair. A and B are only considered. Okay. For an example, let in this particular example, A is the higher frequency character and P is the lower frequency character. If you move left to right and apply this algorithm, this part of the code where lower frequency character having more frequency as of now than the higher frequency character current frequency. For example, here P's frequency is 1 and A's frequency is 0. So this will make both of the frequencies of higher and lower characters to be 0, which would be P's frequency will be 0 and A's frequency will be 0. And again, only higher frequency character will be having a frequency greater than 0 and P would be having a frequency equal to 0, and in this case the variance would not be considered. So to resolve this case, we would be once checking for the left to right direction and once checking for the right to left direction. For that we can just reverse the string and apply this logic 2 times. That's what I have done. Rest the code is well commented and you can understand from it. The code is also available in C++, so you can check it out on the GitHub repository on which I will be uploading it. So thank you for watching. Subscribe with my channel for more such content. Thanks.